this subsequent part here. Now, this is very important because theta is equal to the basic angle here. Okay, so since in the first quadrant all is positive, so we can just write this as positive sine alpha, positive cosine alpha, and positive tangent alpha, meaning these are all positive, right? Alpha is actually an acute angle, so it happens to be alpha equals to theta. So first quadrant typically is easy because you can't really see how ASTC is being applied for the first quadrant, okay? But just take note, when your angle is in the first quadrant, it's just sine alpha, cosine alpha, and tangent alpha, where alpha is the basic angle, okay? Basic angle or the reference angle. Now, it may seem redundant, but sometimes theta can be like, let's say, 380 degrees. Okay, 380 degrees, although it looks like a huge number here, okay, but it falls within the first quadrant, because if you have 380 degrees, you work from here to here. This is 380 degrees. One round is 360, so this will have an additional 20 degrees in the first quadrant here. So the basic angle, which we have already covered this, is actually 20 degrees. Okay, so you can actually write down, so example, you know that cosine 380 degrees can be written as, this is the first quadrant, is the same as cosine 20 degrees, because this is actually just the alpha, and then sine 380 degrees will also be sine 20 degrees, which is the basic angle, and tangent 380 degrees is as well tangent 20. Okay, so that's the reason why we have ASTC here. Okay, so just take note. I think first angle, the first quadrant is pretty okay because all are positive. Let's look at the next one, second quadrant. Now, if you have an angle in the second quadrant, what you need to know is actually only sine is positive. Okay, sine theta is positive. Then after which tangent and cosine, they are negative, because this is AS, only S is positive, ASTC, right? Okay, so this case here, what we're going to do is actually only sine. So this will be sine alpha. Okay, now sine acute angle is always positive. The alpha is, this basic angle here is always positive. So just take note that this will be sine alpha. Cosine theta will be actually cosine alpha. But because this is acute, this will always be positive. You need to add a negative in front. So you just put negative tangent alpha here. Okay, so that's a negative cosine alpha and negative tangent alpha. Just take note of that. In the second quadrant, right? Yeah, so in the second quadrant, theta is actually 180 minus alpha. So just look at this diagram, you'll be able to tell. So same thing, I'm going to go quickly do the third and the fourth quadrant, okay? Third quadrant, you know that only tangent theta is positive, the rest are negative. So this will be tangent alpha, and it's a positive tangent alpha here. So it's tangent alpha, all right, positive one, and this will be negative sine alpha and negative cosine alpha. There you go. Then for the fourth quadrant, sine alpha will be, it's only cosine is positive, so cosine alpha is positive here. Then this will be negative sine alpha, and this is negative tangent alpha. Okay, that's about it. So we use the basic angle to simplify. Actually, we use basic angle to simplify the ASTC, to find the trigo ratio. Okay, it's actually quite useful, because we know that for the basic angle is always positive, and coupling with what we learned about ASTC, which is positive and negative, we just need to attach a positive and negative sign in front of the trigo ratio. Okay, so let me just color code this for you. So this is a positive in the third quadrant, this will be the positive in the third quadrant, and this will be positive in the third quadrant. Okay, so let's see how we can actually use this concept here in the subsequent parts. Okay, any question, please let me know, and I'll see you in the next question.